Hi, I am Micaiah with Txtx, and I'm going to demonstrate a Solana or SVM runbook here, where we can deploy a program to Solana and any SVM compatible chains, super simply and easily using Txtx. So here I have a runbook that let's start right here on the add-on SVM. So we are using the SVM add-on, and we're setting some values here that are coming from these flows we define above. I'll explain more of that in a second, but just to run through the rest of this, we have a signer and we're naming it deployer, and the type of signer is it's using a secret key. We can also have a web wallet signer where we're signing things in the browser with a web wallet and we don't need to manage our keys. But for simplicity, we'll just use the secret key signer here. We're setting up a variable called program, and we are able to just get the program from an Anchor project just by using the name of the program. And then we're passing that program and the signer to this deploy program action. And then finally, we're outputting the signature of the transaction. Real quickly, I'll show this is just a simple hello world. We're just logging, hello, whatever we pass in. And that's the program we'll be deploying here. And I have this one flow defined. So essentially the way these flows work is for each flow that we just define, this entire runbook will be executed. And so we have a flow called Solana, and we're setting up some network parameters here for it. These input values, they come from this manifest here. So we've got different environments that have those values defined. So like if we deploy to localhost, then this will be our API URL. If we deploy to DevNet, then this will be our URL. So yeah, let's run this. So if I do txtx run, the name of this runbook is deploy, and then -u, this will be our unsupervised mode, and it's just going to execute it. And then I'll also we'll do this one on DevNet. So env DevNet. So there's quite a few transactions here that need to be sent for the program deployment. While that's working, I'll also mention our state file. So Txtx manages the state of your deployments. So if we once this one's done, if we execute again, there's no change in the program, so it's not going to redeploy it unless if we make some change to the program and recompile it, then we will have Txtx will detect a diff in the compiled code versus what we've already deployed on chain, and so it will re-execute the runbook. So we kind of manage the state for you, so you don't have to worry about accidentally deploying the same thing or wasting fees on redeploying something. And I'll demonstrate that in just a second. All right, program created. And so now if we do txtx, same thing, we'll run it again. We'll see latest snapshot in sync with latest runbook update. So there's no changes here. Now, if we uncomment this flow, so now we are deploying to Solana as well as to Eclipse. So now we can run that deployment again. We'll see new chain to synchronize Eclipse. Do you want to continue? Yes. And it's going to deploy the whole program to Eclipse as well now. Okay, so we have deployed our program now to Solana and Eclipse, and if we run that again, we'll see there's no changes to make. If we go in and, so say we want to change this string, we can redeploy this. We'll do a anchor build, and then we can run our deployment again. We will see this diff of what's changed, and for each of our flows, we can see what actions need to be redeployed. We can also use Txtx to call this contract or this program. So, okay, so we have this get program from Anchor project once again. So we're getting the program. This time we're using a web wallet. We're just saying what address we expect to connect here. We can create these variables that can be edited in the supervised execution mode for the instruction and the arguments we want to pass. And then, so this time we're going to use the SVM process instructions command, where we can just put any number of these instruction blocks, and we're saying what program ID we're going to use, invoke here, and then we can set up the account data with this account function. So we're the same address that is the signer here will be a signer and will be mutable, and then we can just get the instruction data directly from the IDL here. So we can just pass in our program's IDL, we can pass in the instruction we want to call, and we can pass in the arguments. And Txtx is automatically going to be able to type check the instruction and the arguments you provide based off of the IDL to make sure that the data you're sending is valid here. So here we can do txtx run call. We'll do this one on devnet as well. Oops, env devnet. And so this is on localhost 8488. If I go here. Okay, so we need to connect our wallet. Phantom wallet. There we go. All right, and then we can provide our public key. We can see the balance of our signer. We can see the program that we're going to be calling, the instruction, as well as the arguments. And then we can see the call that we're going to be making. We can click sign transaction. And the simulation does not pass on DevNet here, but we can confirm anyway and validate. And this is being broadcasted to DevNet. And so now we have the data that was sent as well as the signature, and we have signed a transaction in the browser and broadcasted it to the Solana network.